Well, hey there, kiddos. Here is your last video, Transformations Day 3, or not your last video, but your last video on transformations. So this is Transformations Day 3, and you will see that it says changes of M and B. So we're changing both the slope and the y-intercept today. So we're basically just taking the last 2 days and we're putting them together. And so if you look number 1 here, we've got the parent function y equals x, which is already graphed, and then we want to graph y equals 2x minus 3. Well, remember, to graph a function, we start at the y-intercept, which in this case is negative 3, and then we use the slope, which is 2, to find a new point, so I go up 2 and over 1, and then I can go backwards and down 2 and over 1. And so then I will get out my ID or a ruler, or in my case, my pretty little straight line, and I will continue that, and hopefully you see what the new graph looks like. So this is our new graph. This is the 2x minus 3. And so what is changing? Well, we changed the slope by increasing it because it went from a slope of 1 to a slope of 2. And then we changed the y-intercept and we decreased that because it went from a slope of 0, or sorry, a y-intercept of 0 to a y-intercept of negative 3. And so how do these two lines compare? Well, my new line is definitely steeper than the other one. So my y2 is going to be steeper, and it is also translated down because its starting point went from 0 to negative 3. And so it also got translated down. So two things happened. It became steeper, and it translated down 3 units. So let's look at the next one, number 2. I've got my parent function, y equals x, it's already graphed, and then I have 1/2 x plus 2 that I need to graph. So I'm going to start at 2, which is my y-intercept, and then my slope is 1/2, so I'm going to go up 1 and over 2, up 1 and over 2. And I will connect them and make a line. And so there's my new one. So this is the 1/2 x plus 2. And so again, what changed? My slope definitely changed. And my slope this time went from 1 to 1/2, so it decreased. And then my y-intercept increased because it went from a y-intercept of 0 to a y-intercept of 2, so it increased. And so if I look at what happened to this graph, my new graph is less steep than the old one, so it's flatter. I made that slope get smaller, so I made my graph less steep. And my starting point, my y-intercept, translated up 2 units. So this one is also translated up. Now the next one's where it gets really interesting, because now I don't have a parent function to start with this time. I'm just starting with 3x minus 1, and then I'm going to do negative 3x plus 1. So we're going to do both of these and talk about what happened. So the 3x minus 1, starting point is down here at negative 1 for the y-intercept. Then my slope is 3, so I'll go up 1, 2, 3, and over 1. And I'll connect those points and make my line. There we go. So that's going to be my 3x minus 1. And then I'm going to have to do my negative 3x plus 1. So let's grab a different pen here. So my 3x plus 1, this one has a starting point at positive 1. So that's my y-intercept. My slope is negative 3 this time, so I have to go down 3, 1, 2, 3, and over 1. And I can connect those points and make a line. So that's my negative 3x plus 1. So what changed? Well, let's see. I didn't change the slope. The slope was 3 and the slope is 3. So both of them have a slope of 3. So the steepness is not going to change. I did, however, change the sign of my slope. So I did change the sign on the slope. It went from positive to negative. And so it went from a positive slope to a negative slope. I did change that. I also changed the y-intercept, and the y-intercept went from a -1 to a +1, so it definitely increased. It went up, it got bigger. So let's talk about what happened. The steepness did not change. This blue graph is the same steepness as the red graph. They're just going opposite directions. And the reason for that is because of the negative. The negative reflected the graph, so it is reflected over the x-axis. And this going from -1 to +1, it translated my graph up because I went from a negative to a positive, and it went up, and if we'll count, it went up 2 units because from -1 to +1 is 2 units on the number line. So it reflected and got translated up, but nothing happened to the steepness because I didn't change my slope, the actual number. So now let's apply this with our pretty little function notation, because that's really pretty important. And so our function notation here is f of x equals 3x. Well, let's just start with that and get that graph on our paper. So we're going to start with f of x is 3x. Well, that means the y-intercept is 0 because there's nothing added or subtracted here. So it's plus 0. And so I'll go up 3 and over 1. Connect them and make my line. So there is the first one. Now let's look at y2. y2 is 1/3 f of x minus 1. Well, if f of x is 3x, then what that is saying is that I want to do 1/3 of 3x minus 1, because f of x is 3x. Well, 1/3 of 3x, if I do 1/3 times 3, that makes 1. So really, I'm going to have to write it up here. My g of x becomes 1/3 times 3 becomes 1x minus 1. So I'm going to graph that. So it's going to start at -1 because of my y-intercept, and then my slope is 1, so I'm going to go up 1 over 1, up 1 over 1. Make a bunch of points here so I can draw my line. So there's that one. So let's talk about what happened between those two. So from f of x to g of x. So if I went from f of x to g of x, the things that were changing were the slope. It went from 3x to eventually 1x, so it decreased. And I also changed my y-intercept and went from 0 to -1, so the y-intercept also decreased. And so the changes that happened from f of x to g of x were that it got less steep because of the slope, and it translated down 1 unit because it went from 0 to -1. So that's what changed, and that's what it did, that change made. So now let's look at h of x. So I've got f of 2x plus 2. Now if I want f of 2x, that means I've got to plug 2x in for my x. Well, in this case, I've got 3x. And so I have f of 2x, which means I have to do 3 times 2x. So I've got to replace the x with the 2x plus 2. And then I've got to simplify that. Well, that becomes 6x because 3 times 2 is 6 plus 2. So I'm going to start at 2 for my y-intercept, and then my graph will now become 6x. So I've got to go up 6, 1, 2, 3, 4, 5, 6, and over 1. Then I go backwards down 1, 2, 3, 4, 5, 6, and over 1. And I can plot those points and make my line. And so now we can discuss what changed. And so the things that changed from f of x to h of x. So those are that's where I'm going. So f of x, the slope was 3, and h of x, the final slope was 6. So my slope increased. And then in f of x, I had a y-intercept of 0, and in h of x, I have a y-intercept of 2. So my y-intercept also increased. And so the changes that occur because of that, it becomes more steep, it's steeper. and it's translated up 2 units. That's an A. So now we're going to apply this. So we're going to have this function f of x equals 2x plus 3, and I want to talk about what happens. So how does 2x minus 3, I think I said plus, I meant minus, compare to the parent function y equals x? Well, the slope changed. It went from 1 to 2, so it increased, so it is a steeper line. And then it went from a y-intercept of 0 to a y-intercept of negative 3, so it is also translated down 3 units. So that's how they compare. So now how would the graph change if the 2 in this equation up here was changed to a 5? Well, if I change that 2 to a 5, it becomes 5x minus 3. So I've increased my slope, so it becomes even steeper. And then if I change the 2 to a 1/2, well, now I'm decreasing the slope, so this becomes less steep. And then if I change that negative 3 to a 6, I'm changing the y-intercept from a negative 3 down here to a positive 6 up here, so it gets translated up. And from a negative 3 to a positive 6 is 9 units, because you have to go 3 units to get from negative 3 to 0, and then you've got to get 6 units to go from 0 to 6, and so that 3 plus that 6 makes 9. So now predict what would happen if I change the slope of the function to a negative 1/2. So from a positive 2 to a negative 1/2. Well, first of all, we should recognize that if this is 2 over 1 and that's negative 1/2, that these two lines are going to be perpendicular because you have flipping opposite slopes. They're opposite reciprocals, so they'll be perpendicular. But the negative, what really happens is the negative reflects that graph, so it's reflected, and it's going to be less steep because it's going to go from a 2 to a 1/2. So it's less steep, which is what makes it possible for them to be perpendicular and not just intersecting. So summary of everything that we've talked about: slope, if you'll remember, affects the steepness of the line. The bigger the number, the steeper the slope. The smaller the number, the less steep the slope. And then the y-intercept affects the starting point. It affects where that graph begins on the y-axis. And so it translates the graph up and down. So this translates up or down, depending on the number. And so now we're going to look at your practice really quick. When you come in tomorrow, we're going to do one together. We're at least going to start it because it's all in terms of function notation. It's all this f of x and g of x stuff. So I want to make sure we're all good with it. So be prepared at the beginning of class tomorrow to pull out your practice and walk through one with me. Until then, have a good rest of your day. I'll see you tomorrow.